This next module is about casting. This chapter is entitled Advanced Operators, and the cast is not really an operator, but I've put it here because it affects the behavior of all the other operators. You can almost think of it as an operator in the same way that you can almost think of size of as an operator. So, let's find out what casting is. A cast is used to cause the compiler to temporarily pretend that the piece of memory used by a variable is actually of a different type. What does that mean? It means, for example, if I've got an integer sitting around somewhere, I can pretend that that integer is actually a float, or I can pretend it's something else. Let's see an example of that. If you have x is equal to 13, now what's going to happen here? I want to print out the value of x divided by 2. Now obviously x divided by 2 is 6.5, but if all I did was the following, x divided by 2, that final line of code on the screen, then I wouldn't get 6.5, I'd just get 6. Remember, because C always lops off the decimal places when you're doing integer division, and x is an integer and 2 is an integer, and an integer divided by an integer will always give you an integer. In this case it gives you 6. So if I want the accurate answer, then I can temporarily pretend that x is a floating point number, because this is how C works. When you take a floating point number and you divide it by an integer, you always get a floating point number. So that expression that you can see there, the brackets float, x divided by 2, is actually going to be a float. The whole expression will evaluate to be a float, and thus I can use the %f in the printf. The lower example on the screen, I have to use the %d because integer divided by an integer is an integer. So can you see how the actual cast is constructed? I put the type that I want it to pretend to be inside brackets, and I put that immediately to the left of the thing that I'm trying to pretend is of that type. In other words, the brackets float goes immediately before the x, and that causes me to pretend that the x is a float instead of an int, which is what it really is. Now, also, make sure you don't do this, or make sure you understand the difference between the last line of code and the first line of code. The only difference is I've got brackets around the x divided by 2. Now what will that make a difference? Think about it. When you put brackets in, the thing inside the brackets always gets evaluated first. So the very first thing that's going to happen here is x will be divided by 2. Remember, x is an integer, and so is 2. So x divided by 2, in this case, because it's all happening inside the brackets and it's all happening first before anything else, in other words before the cast, x divided by 2 is simply going to be 6. Not 6.0 or 6.5, just 6, the integer 6. And then that result, the 6, is going to be converted into a float. So we're going to get a float answer of 6.00. You see what's going on here? So what I'm trying to get at is the thing immediately to the right of the cast is the entire answer of the expression x divided by 2. Whereas in the previous example, the thing immediately to the right of the cast was the x. So the top example is correct. The bottom example is incorrect. Make sure you understand the difference why. Now I'll just take you to a piece of code so we can compile that and have a look at it and see if it works. This is cast.c, and it's essentially the same lines of code all over again. I've added one line of code extra at the bottom, which you'll see what that's all about in a moment. Let's compile this and run it. Now we've got 4 answers here. Let's hang on, let's just organize our screen properly. Okay, the first one here, x over 2 is 6.5. Now that's the first and correct answer. Recall that? First correct one. The second one, I just get 6. Now that's all we'd be able to do if we did not have casting at our disposal. Now yes, you're right, we could create another variable called, say, answer, and we could say make that a float, and we could say x divided by 2, answer equals x divided by 2. However, that's just going to give you what this gives you. It's going to give you a floating point representation of x divided by 2. It doesn't solve the problem. We need a cast here. If we want to get an accurate answer of half of an odd numbered integer, an odd integer, if you know what I mean, we have to use a float. So here you can see that this example is not working. 6.00 is what we get, whereas here we get 6. So that's what we would have had before. That's what we would have had if we tried to convert it to a float but we didn't use a cast, and the top example is if we tried to convert it to a float using a cast. In other words, the correct way. Finally, we've got something else going on here. X divided by 2.0. Now what's going on there? Okay, I'm going to switch back to the PowerPoint screen just for a moment to tell you what's going on here. There's something called implicit casting. This is casting that you don't actually put anything on the screen inside any brackets or anything. You don't do a cast yourself, but C does a cast for you. It happens quite a lot, much more often than you would think. For example, given the same example as before, now we have x divided by 2.0. Now recall, x is an integer, but 2.0 is not an integer. It might look like the number 2, but 2 is an integer, whereas 2.0 is a floating point number. So what we've got is an integer x divided by a floating point number 2, and an integer divided by a float, well, that's always answered as a float. So what happens here is that x, if you really want to be technical about what's going on here, the variable called x is implicitly cast to a float just so that the division can happen. X is implicitly cast, so the compiler pretends, just for the purposes of the calculation, that x is a float, and then it does the division, and then the answer is obviously 6.5. So that actually works. Let's go back and examine the code. Here's that code again, x divided by 2.0, and you can see that does actually work. Okay, so I think we understand the mechanism behind what's happening here. We're temporarily pretending that a variable of one type is actually of another type. Let's see a more practical example of this. This is cast2.c in the chapter 8 folder. Now it's actually exactly the same as the size of 2.c that I showed you just a moment ago. Remember, the one that adds up all the things in the array, gives you their total and gives you their average. Okay, now let's go back down to the average line. There's the line of code that calculates the average. Now, what answer do we get? Let's recompile that. Okay, let's get an answer. Is 142.000. Let's go back to the code. We've got the total of all those numbers. Let's say, how many numbers are there? Maybe 22 odd numbers. What are the chances are that all of this divided by 22 is an even number, is an actual integer whole number? Probably not much of a chance at all. However, average is actually a float. It's a floating point number, and we're displaying it as 0.3f. So we're displaying it right, we've declared it right, but we're still ending up with an integer whole number. So if we actually want an accurate average, and I'm stipulating, and I'm just guessing, but I think that the average that we got, 142.000, is not an accurate average, then we need to do some cast here to pretend that one of these variables, either this one or this one, is a float. And I might as well choose this one. We'll pretend that total is a float. So I'm going to here force the compiler to treat the total as a float. So a float then divided by an integer, and size of, the result of a size of is always an integer. So a float divided by an integer is going to be a float. Really, it is. So let's try and compile this again. No errors again, and run. Aha! Now the average is 142.905. Now that is what I suspected. I didn't think it was going to be a whole number. Okay, so now you can see that casting does actually have some useful applications. And when we get up to pointers, which is coming up in a few chapters' time, you'll find that that casting is extremely important when used with pointers, especially when used with something called the void pointer. That's quite a ways away just yet.